Hello everyone, welcome to my topic Circuits and Networks. In today's session, we are going to see the resonance phenomena in series RLC network. And this particular class we are going to take as class 1 because we are going to deal with the basic problem and we are going to treat this particular problem as 1. So this is how we have seen the RLC circuit parameters where you have the source voltage, resistor, inductor, and capacitor all are connected in series with the input supply voltage. So when this is connected in this fashion, that is a series circuit having 20 ohm resistance, zero point 0.4 henries of inductance, 60 microfarads of capacitance, all are in series applied to 110 volts of input supply at a variable frequency. Then under resonance, find the frequency at which this phenomena resonance occurs and find out the voltage drop across each element. That is our target 1. Then estimate the quality factor. That is our target 2. And estimate the upper and lower cutoff frequencies of this series RLC circuit when applied to 110 volts. So how do we solve this particular problem? So the given parameters are resistance, inductance, and capacitance. The numerical values are given. At resonance for series RLC circuit, the resonant frequency is obtained as 1 by 2 pi under root LC. Just substitute the values of L and C in this particular circuit. So we have 1 divided by 2 pi. L value is zero point 0.4 Henry and C value is 60 microfarads. So 60 into 10 to the power of minus 6. So this term under the root, it is going to obtain as 4.89 into 10 to the power of minus 3. And this particular numerical can be obtained to be 32.547 hertz. So this is the resonant frequency. So I have taken here 32.547 hertz because in depth when you're going to apply 32.5 as one value for resonant frequency, you can see the phenomenon of resonance. Then 32.54 will give you the importance of resonance, and 32.547 will give us the estimation for the bandwidth where the resonant frequency is going to challenge the concept of resonance. So this 32.5, 32.54, 32.57, 547 will give you the exact effect of resonance for this series RLC circuit. So let us calculate the current. Current it is nothing but under resonance. The current value is nothing but voltage by resistance. So voltage is this. Current is 20. Voltage is this. Resistance is 20. So the current value is 5.5 amperes. Now this is the value of current under resonance, and we have to estimate the rest of the parameters under resonance. So what will be the power developed in this circuit under resonance is nothing but 5.5 square times the resistance, which is nothing but 605 watts. Now this is the value of the power under resonance. Practically this is not possible, but at exactly the resonance condition, this is the power value for the given parameters of the RLC circuit under 110 volts. So this is what we have obtained as the value of power. And they have asked us to obtain the value of the voltage parameters under the passive element, that is RLC. So the voltage across resistance will be current traveling to that particular resistance under resistance is nothing but 110 volts. Now this is equivalent to the value of input voltage, because the phenomena of resonance states that the voltage across inductor should match with the voltage across capacitor. When they get nullified with each other, naturally the entire voltage is going to be applied across resistance. So this is the conclusion what we can make under the phenomena of resonance. Okay, once we are done with the resistive voltage, let us estimate the inductive voltage as well as the capacitive voltage. So the inductive voltage is given by I into XL. XL is the inductive reactance multiplied with the current will give us the value of the inductive voltage. Then what is XL? XL is the inductive reactance which is given by 2 pi F naught L. What is this F naught? F naught is a value of resonant frequency at which this concept of resonance has occurred. So the inductor value is given and resonant frequency already we have estimated. So let us substitute the value of XL and I nothing but 5.5 under resonance. So this gives us the value as 5.5 multiplied with 2 pi. F naught is 32.54 multiplied with the inductor value, that is zero point 0.4. So this will give you the value of the inductive voltage to be 449 volts or 449 volts. Now this has to be matched with the capacitive voltage. How do we do that? For that, the formula for capacitive voltage is IXC. What is XC? XC is nothing but 1 by 2 pi F naught C. So just now we estimate the value of F naught. So substitute the value of F naught at 32.5, the value of pi to be 3.14, 2 as it is, and capacitance is 60 microfarads. Micro indicates the value as 10 to the power of minus 6 in the denominator. So you can shift this denominator to the numerator and this particular value changes to 10 to the power of 6 divided by the values which are there in the denominator. This micro has gone to the top and this has become 10 to the power of 6. So the value of Xc here it is obtained as 81.64 ohms. Since it is a capacitive reactance, that is why unit is in ohms. Substitute this value in the value of voltage. The current value is 5.5 under resonance, so it is obtained to be 449 volts. As accepted result, because it's a resonance concept. In the resonance concept, resonance occurs when the inductive voltage is equal to the capacitive voltage. Thus the resonance has occurred. That's why these two voltages are same. So this is how you cross-examine your result under resonance. Apart from that, what is asked in this particular resonance circuit, they ask us to calculate the quality factor. So in our previous classes, we have seen the formula for quality factor under series resonance, which is equal to 1 by R under root L by C. Just substitute the values of inductor and capacitor as it is. So inductor is 0.4, capacitance is 60 microfarads, micro indicates to the power of minus 6. So this value leads to the quality factor to be 4.08. So this is the value of the quality factor. And at last, we are asked to estimate the lower cutoff frequency, which is F1, which is equal to F0 minus R by 4 pi L, and F2 to be, sorry, this is a small mistake. This should be F2, which is equal to F0 plus R by 4 pi L. So the lower cutoff frequency value will be 32.5 minus 20 divided by 4 pi into zero point 0.4, which is the value of inductor, which is obtained to be 28.52 Hz. And similarly, the upper cutoff frequency, this is supposed to be F2. It's a small mistake. Please ignore this. It should be F2 and whose value will be 32.5 plus 20 by 4 pi zero point 4, which is equal to 36.47 Hz. So this is a value of lower cutoff frequency and upper cutoff frequency. When you estimate the bandwidth, it will be F2 minus F1, which will be 36.47 minus 28.52. So that is how you calculate the bandwidth. So it's a simple numerical what we have understood under series resonance circuits. So we have estimated a simple problem under series RLC network, and this particular session we are treating as numerical 1 and problem 1. In tomorrow's class, we are going to see some more examples under series RLC network. In the later classes, we are going to see the parallel combination under resonance concept, and we'll also see the numericals involved with resonance under parallel circuit. I hope you like my video. So please share and subscribe to my channel and press the bell icon for the future notifications. Thank you.